Hello FPGA community, my name is Michael. Welcome back to course PUF Our FPGA. Today, in part 3, we will start with you in HDL development of PUF using VHDL and Verilog. As we discussed before, we will build with you a simple Arbiter PUF, which consists from few things. It's MUX-pair based delay line and simple D flip-flop. To build an Arbiter PUF, we will need to create a multiplexer, build MUX-based delay line, describe a D flip-flop, and connect these two things together to build an Arbiter PUF. From hierarchy side, we will have 4 modules. It's MUX, DFF, delay line, and Arbiter PUF. It's very simple, as I told you before, but it will be very interesting and complex project. From a project directory side, we will have one main folder and few subfolders. And I suggest to you start our project from creating our project directory structure. So let's create some subfolders. Inside our PUF Our FPGA, it's our main directory, we will create 3 subfolders. Subfolder docs, where we'll save some useful information. Subfolder PRG, where we'll save our projects. And subfolder SRC, where we'll save source code files. In docs directory, we will save some useful and helpful information, like articles and presentations from this course. I will also put in this directory, presentations. In PRG folder, we will save with you our projects regarding development tool. It could be, for example, MATLAB, and also it will be Vivado. In the SRC folder, we will place our source codes regarding file extensions, like CH for microBlaze processor, for Tickle scripting, folder for design constraints, and folder for HDL languages, XHDL. Inside XHDL folder, we will create 2 subfolders. It's Verilog and subfolder VHDL. I also suggest to you create more one subfolder inside these folders. It's required since you will in future develop your own PUFs, maybe from some articles, maybe you will create your own PUF and you want to build and save our source codes independently, and to save project structures, I will suggest to you create subfolder regarding a PUF which you will develop. It's Arbiter PUF for our case, and the same folder we will place inside a Verilog subfolder. So, that's all. We created subfolder structures. Let's start coding. So, we will start our project from developing a multiplexer on VHDL and Verilog. And now we will start with VHDL language. So, create a new project, press next, type project name as Arbiter PUF VHDL. We will save our project in PUF Our FPGA PRG Vivado folder. We will need to create some subfolder. Press this checkbox. Click Next. The type of project is RTL project, and we do not specify source at this time, since we do not have any source yet. Press Next. We will use for our course RT board from Digiland. This board has RTX 7 FPGA from Xilinx, and the name of this FPGA is XC7A35T CSG324, first speed grade. Select, click Next, and click Finish. After a few seconds, Vivado will create a project for us. Now we need to add new source file. Select Add or Create Design Source, Create File, select Language VHDL, type MUX as the file name, and save this file, location, PUF Our FPGA, sources, XHDL, VHDL, Arbiter PUF. Click OK, click Finish. Now Vivado suggests to us using special wizard to create a new module. So let's create and let's do this via this wizard. So architecture name is RTL, and we need to set some ports for our multiplexer. So it will be input A, it will be input B, it will also input select, and one output or out. Set direction out and click OK. As you see, Vivado added our multiplexer as design sources and set as a top level file. So double click to open it, and we will have the template for our module. First of all, delete all unnecessary things and puts some header before our module. This header will consist of helpful information about what is the model, what is the revision, something description, and maybe some change logs. I already prepared some template for this header, and I just need to comment it. So our module will named as MUX, and description will is simple multiplexer. Simple multiplexer. It is very simple to describe multiplexer on VHDL language. For this course, I will use one type of description using when statement. So how to do this? We need type or out will receive data from input A when select signal is equal to 1. In other case, else it will receive data from input B. That's all. Very, very simple, as I told you before. So, to be sure that this is a really multiplexer, we can check it. We can check it by two types of methods. First of this, it's openable elaborated design. It's not a synthesis, it's just a description of your logic on high level abstraction. So, as you see, we really described a multiplexer. But this multiplexer could be implemented inside the FPGA as a lookup table or the special resource MUX-X7. So let's check how it will be implemented inside the FPGA, run synthesis, and press OK. After synthesis complete, we need to open synthesize design. Select open synthesize design and click OK. Vivado suggested to us close elaborated design, so close it and wait while synthesis results will be downloaded. So select MUX, schematic, and we see that our multiplexer will be implemented as lookup table with 3 inputs. Let's check a truth table inside of this lookup table. Select lookup table, go to cell properties window and click truth table tab. As you see, here is a description of simple multiplexer. Logical equation of simple multiplexer. That's all. It's the end of this VHDL description of multiplexer. So close Vivado project. And let's go to describe it on Verilog language. For Verilog language, we will do the same things which we did for VHDL. Let's create project, press next, type project name Arbiter PUF Verilog, save this project to PUF over FPGA PRG Vivado, create project subdirectory, next, select RTL project type, do not specify source for this time because we don't have Verilog sources, click next, select our FPGA which installed on RT board from DigiLand, XC7A35T CSG324. First big rate. Click next, click finish. So this is empty project. We need to add new design sources or create design sources. Select add or create design sources, click next, create file, select Verilog language, type MUX, and save this file to source subfolder VHDL Verilog Arbiter PUF. Click Finish. Let's use wizard for creating template of our module. It will input A, it will have input B, input is select, and output or out. Change direction, click OK. File was created, now open it and delete all unnecessary things. Let's copy our header and we need to comment it. Our model will name it as MUX, and this will be a simple multiplexer. We also have some types of style codings to describe a simple multiplexer on Verilog. Now I will use it, ternary operator, assign or out. If our input is select is equal to 1, we will return to or out data from input A. In other case, we will return data from input B. That's all. That's a very simple description of multiplexer on Verilog. Let's check that this is a really multiplexer. Open Arbiter design. And as you see, it's a really multiplexer. So this multiplexer as an VHDL could be implemented in a site FPGA, like lookup tables, or maybe like a special multiplexer. Let's check it. Run synthesis, click OK. After completing the synthesis, we need to open synthesize design. Select open synthesize design, click OK. Vivado suggested to us close Arbiter design, press yes. Select netlist, multiplexer, and show schematic. As you see, this is also implemented as lookup table. We can also check that truth table of this lookup table is the same as a simple multiplexer. That's all. This is the end of describing multiplexer on Verilog. Close synthesize design and close Vivado project. Today we learn a lot of new things. How to create Vivado project, how to add source files to our project, how to write behavioral description of multiplexer on VHDL and Verilog, how to elaborate design, how to run design synthesis, and how to review of post-synthesis results. For your homework and your practice, I recommend to you try to describe multiplexer using other statements like process and always blocks, if statement, and case statement. This will be also a good practice if you will use some synthesis guides to correct description of your modules. For Vivado, this is UG 901 synthesis guide. If you have questions, please find me at FPGA community Telegram chat, send me an email, find this presentation and source codes on our GitHub, FPGA community, and if you would so support me, please do this via Patreon and donation alerts. Thank you for your attention. See you in the next video.